Hi everyone, my name is Emma Lodato. So today we're going to go mining for salt in a mixture of regular table salt and regular table pepper. The objective of this experiment is to better understand the different properties of matter, and I'll do so by showing a separation process that's based on the physical properties of both salt and pepper. So for today's experiment, we'll need our personal protective equipment, aka PPE, as lab safety, because it's always of the utmost importance. Today, I'll be wearing my safety goggles, nitrile gloves, closed-toe shoes, and pants that fully cover my legs, and a long-sleeve garment similar to that of a lab jacket, but I don't have one, so hopefully this will suffice to wear over my everyday and clothes that I would normally wear to work. Okay, so while today's materials are everyday household items that are rather innocuous and may not seem like they warrant practicing lab safety, it's always good practice to practice good and appropriate lab safety, regardless of how comfortable you may feel or how perceived the risk assessment is. In doing so, it'll help build a force of habit or something like muscle memory and practicing lab safety consistently and appropriately. Okay, so back to today's experiment. So, how I mentioned before, we'll need some salt, pepper, a balloon, and a plate. So in this experiment, you'd actually prefer regular table salt and regular table pepper because they work great for this experiment because they're both really finely ground up. But just a little side note, if you're using very coarse salt and or very coarse pepper, such as whole peppercorns, please be aware that the balloon may accidentally be punctured and abruptly burst. So, all right, now let's start the experiment. First, we're going to take our salt and sprinkle a fine layer over the plate. Next, we're going to do the same exact thing with our pepper onto the same plate. Okay, so what we have here what we just did is that we created on this plate is a mixture, since it's at least two distinct substances, in this case pepper and salt, that have been physically combined. And it's important to note that this is not a compound, because a compound is made up of at least two elements that are combined in a distinct ratio. But both salt and pepper are both compounds, as they're both pure substances that are made up of elements in a specific ratio. For example, salt is made up of the elements sodium and chloride in a 1-to-1 ratio, aka NaCl. And pepper is made up of the elements carbon, hydrogen, nitrogen, and oxygen in a 17:19:3 ratio, aka C17H19NO3. Now, elements cannot be used for the ordinary chemical reactions or normal chemical means to be broken down any further, as they're pure substances. Anything that has mass and volume is called matter, and all matter is made up of elements. Pure substances are a form of matter that has a constant composition with properties, such as chemical properties and physical properties, that are constant throughout the sample. Both elements and compounds are pure substances. Okay, so now let's get back to the experiment. First, we're going to fill up our balloon with air and seal the end to make sure that it stays inflated. I actually really struggle doing this, so in order to have the video be a bit shorter and not have you see me struggle to blow up a balloon, I had previously blown one up for the sake of time. Okay, so we blew up our balloon and we're going to seal the end, tie it in a knot to make sure that it stays inflated. Now next, we're going to take this inflated balloon and rub it against some hair for a few moments. You can see my hair is a little messy now. Okay, so now that we're done, we're going to take the balloon and hold the balloon over the salt and pepper mixture. Are we seeing that? Are we seeing the pepper pretty much jump up to the balloon? Here is the surface of the balloon with the pepper that jumped up on it. Okay, so we're seeing our mixture separate into at least two separate products. The salt, which remains on the plate, and the pepper. And this is using different properties of our mixture's components in order to separate them. This is known as a separation process. Wow, so much static electricity. In our experiment, we used the physical properties of our two substances, salt and pepper, to separate our mixture. By taking measurements and using our senses to observe, we can determine physical properties. Some examples of physical properties include volume, density, mass, melting point, boiling point, color, weight, texture, and electric charge. Whereas for things that can be identified by observing how substances react with a chemical, some examples include reactivity, toxicity, acidity, and flammability. But those are just a few examples of chemical properties. Now, in our experiment, we used the physical property, electric charge, to separate our mixture of salt and pepper. Now, you may be thinking, how can salt and pepper have an electric charge? It's not my iPad or my microwave. What's going on? Well, everything, and I mean everything, from your socks to your pet to the baseball to the food that you eat, and everything else in the universe has an electric charge because everything is made up of very tiny particles that we can't see with our naked eyes. These are called atoms. Now, atoms are the building blocks of everything in our universe, including all of the elements that make up matter. Now, atoms have even tinier components to them: protons, electrons, and neutrons. Both protons and neutrons are in the core of the atom, also known as the nucleus of the atom, while electrons occupy the space outside of the atom's core, kind of spinning around to varying degrees in varying degrees outside the atom's orbit. They're known as valence electrons. Now, everything in the universe has an electric charge: positive, negative, or neutral, with the protons being positive, electrons being negative, and neutrons having no electrical charge. Now, substances can become positively or negatively charged. If a substance loses electrons, it becomes positively charged. Now, if a substance gains electrons, it becomes negatively charged. When there's the same amount of protons and electrons in an atom, the atom is said to be electrically neutral because the proton's positive charges and electrons' negative charges are balanced out and essentially cancel one another out. Now, some substances are more likely to give up electrons more readily than others, and in doing so, they become positively charged. Now, the same is true conversely. Some things amass electrons from other materials, and in doing so, they become negatively charged. Now, back to our experiment. As I mentioned previously, we had to use an electric charge to separate our mixture using static electricity. Now, static electricity occurs when there's a buildup of electrons on something. In our experiment, it was our balloon, and I was rubbing it on my hair. This is the result of our balloon pulling away electrons from my hair when I was aggressively rubbing it everywhere. Ooh, some pepper. And I'm collecting those electrons on the balloon surface, thereby making the balloon surface become negatively charged. So how did the balloon manage to attract the pepper away from the salt so readily, so easily, and so fast? It was like it was jumping up from the plate. Well, this is because opposite charges, like that of positive and negative charges, actually attracted one another. I'm sure we've all heard the saying, opposites attract. So in that case, we have negatively charged balloon and the positively charged pepper attracting one another. Even after all this time of me rubbing the balloon all around the table and everywhere else, it's still rather negatively charged. So you can see more pepper jumping up from the plate. So, on the other hand, the opposite is true for like charges, such as two positively charged substances or two negatively charged things, as they will repel one another. In our experiment, the positively charged pepper and the negatively charged balloon were attracted to one another, which resulted in the positively charged pepper being collected by the negatively charged balloon. It's still collecting. So, as we saw in our experiment, the salt did not move at all while we were holding our negatively charged balloon over regular table salt and regular table pepper mixture. This is because our regular table salt is heavier than our regular table pepper. But if you bring the balloon incredibly close to the plate, you'll notice that the salt moves ever so slightly towards the balloon because, as we now know, opposite charges attract. You can see I'm holding it very, 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 very close. And some of the salt particles are actually jumping and moving ever so slightly. You can see right around here, whoops, there's some salt that had jumped up to the balloon. So, that concludes my experiment. I welcome any questions or comments. Thanks so much for your time. Have a great weekend.